Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is from Introduction to Geometry. Quarter circles are drawn centered at each vertex of square ABCD as shown. So it means ABCD is a square and A is the quarter circle center of the quarter circle, so the radius is AB, and you can say AD, yeah, that's 1/4 circle. And this one, AEHC, here is B, is the center of the circle. The same thing from C, right? The D, now the intersection here. So let us go, given that AB is 12, so AB is 12. Find the area of the shaded region. Shaded region is the intersection point E, F, G, H. So is not a regular shape. It's a little hard, right? Looks like a little complicated. So at first glance, we can easily to realize, to organize, yeah, we really easily to know E, F, G, H. This area is a symmetry, right? Because this is a square and all of them have the same radius, 1/4 circle. So E, F, G, H, easily we can find if we connect this one and E, H, F or E, G. So this is, we cut this shaded region into 4 congruent parts. If we find one of them, the area of one of them, we times 4, we will got all of the area. And EG obviously equals HF, and I mean HO, yeah, and this EO and OF and OG. Of course, O is the center of the square. ABCD is the center of the square. It means the diagonals, right, is the center of the square. So we just, for the example, to find the area of this part, HGO, right? So then times 4. We just need to find this one. Let us is composed by this is a triangle. If we connect HG, yes, and is composed by 2 parts. This is an isosceles right triangle, HOG, and the sector HG. This, so we just need to find these 2 parts area, then put them together and times 4. So if we want to find the sector HG's area, we can connect this one, right? AH and AG. Then we can use the area of this sector AGH, and this is arc, the area for this arc part, right? This is chord and this is arc, this, and we just bow, like a bow, right? We just find the area of this. So we can use the area of the sector AHG, then minus the area of this triangle AGH. So first we want to know, if we know the degree of this, it looks like trisector of this right triangle DAB is really 30 degree or not. So we, at the beginning, we want to find, and we can we can easily to realize to know if we connect HB, AH and AB, they are the same for the radius, and HB also will be the radius from if the circle's center is B and AB and HB will the same radius, and for the quarter circle from the center A, we will know AH equals AB. So if we connect HB, ABH will be an equilateral triangle. So this part will be 60 degree. So it means this angle will be 30 degree. The same thing, same reason, we will find this angle also will be 30 degree. So this part, this angle HAG equals 30 degree. So this is 30 degree. Now we can easily to find the area of this part. So area, this sector, area of the sector AHG, right? This sector, and it's just 1/12, because this is 30 degree, 1/12 of the total circle, r squared times pi. So that's radius, right? 12 is radius, 12 and 1/12, so we got 12 pi. This is just 12 pi. And now we want to find this triangle area of triangle AGH. So we can use 1/2 AB sine C, right? Formula. This also, AH also 12 times 12 times this one times sine 30 degree. So it will be, this is 1/2, so 36, correct? 1/2 times 12, 6, this 1/2 times this 12, 6. Also we can use this way. We know this is 30 degree. This is, we can draw the height on AH from vertex G. Now we got this one. We will get this one. So 90 degree. This 30 degree. So A B C D E F G H I. We call this point is I. So IG is 1/2 of AG, right? So this is 6, 12, so this is 6. IG 6. And this AI will be 6 times the square root of 3. 6 times of square of 3. So we will easily the same way to get the area of, we can use 1/2 area AHG 1/2 times this is 12. AH is 12 and the height is just 6. So the area for this triangle also 36. So we find the area of this bow area HG, right? So equals, that's 12 pi minus 36. 12 pi minus this 36, that's 12 pi. Okay, we find this part. Now we just need to find the area of this one. We want to find the area HOG. This is an isosceles right triangle. Now we can find HG, right? If we got HG, we can find the area of this one. this triangle HOG. So first we will find HG. We know in the we use the Pythagorean theorem. This right triangle, in the right triangle, HIG. Now we know HI well equals, this is 12 minus this side. AH, that's 12, minus AI. So we will got AI minus AI. AI is 6 times square root of 3, right? AI. We got this AI. Then squared plus IT squared, that's 6 squared. Okay. If we find HG, we will find the area of that. So square root of this, that's we can factor out, or we just do it. So we can factor out 6 here, 6, then squared, then that's 2 minus square root of 3, then squared, right? Plus 6 squared. So we can factor out 6, right? This is 6 squared, and inside is, this square is 4, plus this 3, 7, plus this one is 8, minus, and what's this one? And it will be 2 times square root, so it's 4 square root of 3. So this one we know. Yeah, we just keep this one, and because we need HG squared. Yeah, we know HG squared is just, we just use this one. So okay, let's find the, for this one, for the HO. So HO is HG over square root of 2, right? And the area for HGO is 1/2 times, because HO equals OG, so 1/2 HO squared. HO squared, it means 1/2 times HG over square root of 2, then squared, right? Now we will go back here. We will come here. So that's how much for that? 1/2. These 2. So area HGO equals 1/2 times 1/2 is 1/4, and HG squared, right? Okay. So the total area for the shaded part, it will be 4 times of this, 4 times this, and plus 4 times of this, the area of the bow, right? So the area we want shaded region, area of that, it will be 12 pi minus 36 times 4 plus this HG squared times 4 over 4 times 4, so equals 48 pi minus 144, right? Plus HG squared. So HG squared, we just use use this one. Inside this one, the square, it will be this square. It will be 144, right? 12 square plus this 36 times 3, 108. Then plus this square, 36, then minus 2 times 12 times 6 times square root of 3. So that's cancelled. It will be 48 pi, this part, and plus 144. So this minus 1 for this 144 square root of 3. So we can figure out this all of them is 144. Also we can figure out 144 if we times 3, 48. That will be pi plus that's 3, right? Minus 3 times square root of 3. So factor out 48, right? 48 times pi. 48 times 3 is 144 and minus 3. Yes, that's it. That's the final answer. We got it. Done. So this problem is a little complicated. So I think the most important idea at the beginning we solve this one, we should realize the perfect symmetry of the shaded region. Then we just cut into 4 congruent parts, because we have the 4 same quarter circle. If we got 1/4 of this one, it's easy for us to calculate 1/4 of the we wanted area, and it go ahead to split into 2 parts. One easily to find the bow area of this bow, and then we can easily to get this area of the isosceles right triangle. Yeah, at first we just proved this is 30-degree, right? This angle, and all of them will be can be fluently to solve. I hope you enjoy this one. Thank you. Meet you. See you next problem.